Welcome back to another math video at Math Rocks with Mr. Cox. What this video is going to be all about is looking at figures like this that have a whole bunch of different angles and also shapes within them. And we're going to be looking at some angle types that will appear in there and how they're related mathematically to each other. So angles like vertical angles, or what if we have a linear pair of angles or triangles? How are those angles related to each other mathematically, and how we can use them to actually figure out the measure of all the different angles we see in a shape like this. So with no further ado, let's get it on! The first angle we're going to look at in terms of angle relationships is what's called a vertical angle. And you can look over here in the drawing, and this happens anytime you have lines that intersect, is that the angles that are directly across from each other are going to be equal in measure. So for instance, if this top angle that's here and it's highlighted in pink, let's say that was 100 degrees, what we know is the angle directly across from it is also going to be 100 degrees. Or take the ones on the sides here on the left and the right. Let's say this angle on the left was 80 degrees. That means the one on the right must also be 80 degrees as well. So we call that being congruent, and all that means is that the angle measures are equal. All right, the second type of angle relationships are what we call a linear pair. And what it looks like over here in the figure is we have a straight line down here at the very bottom, and these two angles, the green one and the pink one, make up that straight line. Well, what we know is if we had a circle, we would have 360 degrees. And I'm going to go ahead and just draw like over here. So if I were to draw a circle, but only half of it, that's what would be represented right here. So if a circle has 360 degrees, that means that this straight line is going to have a total of 180 degrees. So what we do is we call that supplementary. So supplementary means that the sum is equal to 180 degrees. So once again, if I know one angle, I definitely know the other. So let's say this angle over here was 70 degrees. What I now know is 180 minus 70 must equal this other angle here. And we all know that 180 minus 70 would be 110 degrees. So that is what we call a linear pair. It's a pair of angles that make up a line, and they're always supplementary. Finally, the third type we're going to talk about in this video is going to be what we have over here. We have a triangle. And so there is a theorem that was made up a long time ago. And what it says is, it's called the Triangle Angle Sum Theorem. And what it is that all angles, all three of them in a triangle, it doesn't matter what triangle you have, if it's equilateral or scaling or a right triangle or whatever you have, the angles are always going to add up to be 180 degrees. So in other words, they're always supplementary. So what this helps us do is if I know this angle down here, let's say that's 50, and I know this angle over here, I'm just going to call this 60 degrees. Well, so far we have 50 degrees, we have 60 degrees. So if we were to take, and we wanted to figure out this last angle over here, if we took 180 degrees, because that's what they all have to be, subtract 50, and then subtract 60, that's going to be the measurement of this pink angle down here. So that would be 7 degrees. So those are the three types of angle relationships that we'll be using in this video. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to part 2. Let's go ahead now and use what we learned about the angle relationships to solve for A, B, and C in this figure over here. We're going to use those geometric relationships and also how they're related mathematically to actually solve for A, B, and C. So looking over here, I see A used in two different angles, and I happen to notice that if I take the 7A plus 7 angle and also the 10A plus 3 angle, that together that forms a linear pair. So that's going to be my first move here in solving for A, B, and C. So I have a linear pair of angles, and what we learned earlier is they are going to be supplementary. That is our mathematical relationship. So let's go ahead and use these two angles. We're going to add them together and set it equal to 180. So I'm going to say 7A plus 7 plus 10A plus 3, therefore would equal 180 degrees. That's what supplementary means. And from here, we're just going to solve it. So 7A and 10A would be 17A's altogether. 7 plus 3 is 10. I'm going to go ahead now and subtract 10 from both sides. So if I subtract 10 here, I get 17a only. And if I subtract 10 over here, I get 170. And then finally, I'm going to divide by 17 on both sides. So therefore, a is 10. So that is going to be our first of our three answers. A equals 10. Going back to this, I can now know exactly how many degrees are in this angle here because we know that a is 10. So therefore, if I want to know that angle right there, I would take 7 times 10, which is 70, and I would add on 7. So 70 plus 7 is 77. So this angle over here is now 77 degrees. I also happen to notice now we have a triangle. And I know now what two of those angles are. One is 42, one is 77. So if I want to figure out my third angle, which in this case is B, I'm going to use the Triangle Angle Sum Theorem. So I'm going to write out TAST as kind of an abbreviation. So Triangle Angle Sum Theorem. And I know their mathematical relationship is that those three angles are supplementary. Once again, that means they add up to be 180 degrees. So I can say that B plus 42 plus 77 would equal 180 degrees. 42 plus 77, if we add those together, we would get 119. So B plus 119 would equal 180. And then finally, if we subtract 119 from both sides, 180 minus 119 would be 61. So B would equal 61. And then our final move is going to be looking over here. If we know this angle is now 61 degrees, and we do, what we can notice is that angle C and angle B are what we call vertical angles because these are two lines that intersect and they're on opposite sides over here. So therefore, I'm going to write in the corner over that we have vertical angles. And just so you know, the abbreviation for vertical angles being congruent would be, rather than writing out congruent, I'm just going to put the equal sign and a little squiggly above it. So vertical angles are always congruent. So therefore, B will equal C. And since we know that B is 61, therefore we know that C is also 61 as well. So that's it. That's how you could use the Triangle Angle Sum Theorem, vertical angles, and linear pairs to actually solve for missing angles inside a figure like this. Hope you stick around for part 2. We'll be talking about 3 more types of angle relationships. Thanks.